Transport Model. Module 3, Application of Operations Research and Application Transport Model. Concept. The transport method is a unique application of linear programming whose objective is to determine the transport scheme that minimizes the total cost of this, knowing the unit costs from origin I to destination J. Functioning. The formulation of a transport problem, following a linear programming model, will be where Z, total cost function, to be minimized. Sig, cost of transporting a unit of product from origin I equals 1, 2, m, to destination J equals 1, 2, n. Zig, quantity of product transported from origin I to destination J. By, available quantity of product in each origin I. Dj, quantity of product demanded in each destination J. A feasible initial solution. For methods can be used, northwest corner method, row least method, column least method, and Vogel's method. If the feasible solution contains m plus n, 1, basic variables, it is called non-degenerate, and if it is made up of less than m plus n, 1, basic variables, it will be degenerate. Non-traditional transportation models. The application of the transport model is not limited to the transport of articles. This section introduces two non-traditional applications in the areas of inventory and production control and tool sharpening service. Transport algorithm. The basic steps of the transport algorithm are exactly the same as those of the simplex method. However, instead of using the regular simplex table, we take advantage of the special structure of the transport model to organize the calculations in a more convenient way. Step 1. Determine an initial basic feasible solution. Step 2. Use the optimality condition of the simplex method to determine the input variable from among all the non-basic variables. If the optimality conditions are satisfied, stop. Otherwise. Step 3. Use the feasibility condition of the simplex method to determine the input variable from all current basic variables, and find the new basic solution. Go back to step 2. In the example presented, it is sought to find the optimal solution for the minimum cost of transportation of the requested demand. The variables on which the model will depend were identified. Once the variables and restrictions were identified with the help of Excel and the Solver tool, an optimal solution was reached. With this tool we can find the optimal solution to minimize the transportation costs of the demand that the problem required, reaching as an optimal solution a cost of $313,200. A graphic diagram of the problem was made, which helps with a clearer and broader vision for a better understanding of the solution to be reached. This has been all for me regarding this model. Thank you for your attention. This has been all for me regarding this model. Thank you for your attention. This has been all for me regarding this model. Thank you for your attention. This has been all for me regarding this model. Thank you for your attention. This has been all for me regarding this model. Thank you for your attention. This has been all for me regarding this model. Thank you for your attention. This has been all for me regarding this model. Thank you for your attention.